Welcome back, aspiring professional Python devs, to mCoding. I'm James Murphy. Let's learn how to set up logging in your Python application the modern way. That means we're going to learn to stop doing this and start doing this instead. As always with so-called best practices, these are general guidelines that work for most use cases. However, you know what's best for your code way better than I do, so if you have a good reason, then do what you know is right. Don't blindly follow this advice if it doesn't work for you. With that said, let's get going, right after I sponsor myself. At mCoding, we do code reviews, consulting, and professional training. Do you have a problem with your code, worried about your architecture, or do you just need some extra dev hours? Why not make me part of your team? Anyway, let's get back to logging. The built-in logging package is very old and full of stuff that you shouldn't use. It doesn't follow PEP 8, the docs are a mess, and many tutorials are outdated or, quite frankly, written by people who obviously don't use it. But for all its quirks, the built-in logging package is the de facto standard for logging in Python. It doesn't matter if you're using a cloud provider or just developing a local application. The standard is the built-in logging package. But do you really even need logging at all? Hey man, you came to me. If your app doesn't need logging, that's up to you. I'm just here to show you what's possible. All right, let's see how to get started. You might think you just import logging, make a logger, set it up with basicConfig, and then get to logging with your messages. When you run the code based off the log level you set, you see those level messages and worse. And I wouldn't blame you if you've been doing it this way. In the most basic cases, this is totally fine, but I don't really recommend doing it this way. Why? Well, if you care to do logging at all, you probably want to log to at least two different places, like to stdout and also to a file. Or you want to log higher priority things like errors and exceptions differently. Maybe you want to send an email if there's an exception thrown in prod. You can manually make handlers and filters and add them to your loggers, but trust me, just don't do it that way. Instead, use dictConfig. For some reason, dictConfig is hidden away in this logging.config submodule and not so much as mentioned in the main logging docs. As the name suggests, this lets you configure logging via a dictionary that explicitly lists all of the necessary components of your logging setup, namely the filters, formatters, handlers, and loggers. The basicConfig hides these objects and their relationships from you, which makes for a really slick one-liner in the most basic case, but for more useful logging setups, I find it's much clearer to list them explicitly. It can get really confusing if you don't have a good mental model for what these things actually do. So here's the one picture to keep in mind to see how it all fits together. Loggers are the things that you actually use in your code. They have a .info, and you can call logger.info to log a message, logger.debug to log a debug message, logger.exception to log the in-flight exception, etc. That creates a log record, which is an object that contains all kinds of useful contextual information. Things like the message and severity, the current time, the current thread or async task, the location in the source code, and so on. Every logger can set a level to drop all messages below a certain severity, and optionally some filters to drop or alter messages along the way. So you could do something like drop all messages that begin with some annoying string, or you could do something more sophisticated like censor private user data that isn't supposed to appear in logs. The logger then passes these log records off to each of their handlers one at a time. Handlers tell you how and where to log a record, like to stdout, to a file, over email, or to a commercial log service. Each handler receives the log record, and just like for loggers, the handler has a level and some filters that allow it to drop or alter the message along the way. If a record is dropped by a handler, it still passes on to the rest of the handlers, but if it was dropped by the logger itself, then it's dropped for good. Assuming the message passes through the levels and filters, when it comes time for the handler to actually write the log message, it needs to write text, but currently this is a Python object. So each handler has a formatter that it uses to convert the log record object into a string to be sent out. The formatter is what lets you customize what an individual message looks like. Like, is it the log level and then the message, or level then timestamp the message, or maybe you write JSON, or maybe you write some other format. Formatters are typically where you see the most customization because it's the formatter that selects which data from the log record to actually include in the message, and that depends a lot on your specific use case and what you want to see in your logs. And this is almost the complete picture, except this is the picture for the root logger. The root as in the root of the tree of loggers. Loggers are accessed and created by name, and if you split the name by dots, then you end up with a tree of loggers. So the a.x logger is a child of the a logger, which is a child of the root. By default, once a child's done handling a log record, it passes that record up to its parent. So if this log record was generated down here in the a.x logger, all of a.x's handlers would run, then it would propagate up to a, and all of a's handlers would run, then it would propagate up to the root, and all of the root's handlers would run. This is done to make it easier for users to disable messages from whole subsystems just by disabling certain loggers. Once again, if a record is dropped by a handler, it will continue moving on to include propagating up to the parent. But if it's dropped by a logger, then it stops and doesn't propagate. But slow down there. This is way more flexibility than you would usually need. Having all these handlers and filters and propagation at different levels is unnecessarily complex for most use cases, and it often leads to subtly broken configs. So here's what I recommend. See all these non-root handlers? Delete them. Unless you've got a good reason, put all handlers on the root logger. This is simpler, but also having all handlers on the root logger ensures that any messages generated by third-party libraries get logged and formatted the same way as messages generated by your own application. Filters? Same deal. There's a decent chance you don't need any filters at all, but if you do, put them all on the root logger or their handlers. Leave propagation turned on, which is the default, so that all messages propagate up to the root logger. However, don't use the root logger in your code. If you use any of the top-level logging functions like logging.info, this uses the root logger, so don't use any of those functions. Make sure to use your own logger, which you get by using logging.getLogger and passing in the name of the logger that you want. This will create the logger first if it doesn't already exist. Then you can use your logger.info instead of logging.info. And remember, your logger doesn't have any handlers on it. We're depending on propagation to send all events up to the root logger and have the root logger actually handle the events. If you have a small to medium-sized application, a single non-root logger is all you need. If you have a very large application, then you should make one non-root logger for each major subcomponent of your application. You definitely don't need a logger for every file. That'd be a waste because these are globals that live for the entire life of the program. With that all in mind, let's get back to configuring logging for a few common setups using dictConfig. As a baseline, let's just have a simple config that logs everything to stdout. If you're ever confused about the config, draw it out like this and then use the picture to fill in the config. This version is required and the only valid value is 1. This is so that they can change everything in the future without breaking old code. Disable existing loggers does what it says. It disables anything that's not explicitly listed in this config. I'm going to go ahead and set this to false so that I can get log messages from third-party code. No filters in this configuration, so let's just delete that. Next, define a formatter named simple and give it a simple format string. We didn't specify what class this formatter is, so by default, it just uses the built-in logging.formatter. It accepts the format string like this, using this kind of weird printf-style format string. Yes, it's kind of weird, but just deal with it. Or, foreshadowing, wait a minute and we'll see a better way. If you want to customize your own format, you can find a list of all the available variables in the logging documentation. Next, we need to define the single stdout handler. So we create this single handler named stdout and set our simple formatter as the formatter for this handler. In order to get it to actually log to stdout, we set its class to the built-in logging stream handler with a stream of system.stdout. The !// here means external, as in this is a variable that's defined outside of this config. And voila, in just 16 lines, we've configured what the basicConfig did in 1 line. I know, but keep in mind this more verbose style is going to be a lot clearer when we have more going on, so stick with me. Despite the fact that we're using dictConfig, that doesn't mean that we need to keep the logging configuration as a literal dictionary in our Python source. Nothing wrong with that, but many find it convenient to keep the logging config in a separate file in JSON or YAML format. Personally, I prefer to keep my config in JSON, so go ahead and create a JSON version of your config, then load that JSON when your application starts. If you wanted to use YAML instead, it would look basically the same, except of course you would have a YAML config, and you would import YAML and do a YAML load instead of a JSON load. Let's bring those side by side just so you can see the two configs. Obviously, YAML is a lot more condensed, but I find it to be a lot more error-prone as well, and also there's no YAML parser built into Python, whereas there is a built-in JSON parser. So if you wanted to, you would have to pull that in as a dependency. PyYAML is a popular choice. Keeping the log config in a separate file also allows you to let your users adjust the logging to their preference. You know, if you trust your users to do that kind of thing. Second setup. Let's modify the config so that errors go to standard error, and then all logs go to a file. Change the stdout handler to standard error and set its level to warning. Then create a new handler and set its class to a rotating file handler. A rotating file handler keeps appending logs to a file until it reaches a certain size, in this case 10 kilobytes. After it reaches 10 kilobytes, it creates a backup and starts a new file. After 3 backups, it starts deleting the oldest one. 10 kilobytes is a pretty small limit. This is just so that you can see the rollover happen. You probably want to pick a few megabytes. After running the script a bunch of times, you can see it eventually created this myapp.log.1 and then started using myapp.log again. We're still using the simple formatter here, but since we're saving to a log file, why don't we include some extra details? We accomplish that by adding this new detailed formatter and setting it as the formatter for the file handler. We include much more information in the format string, and we're also showing off the date format here, which allows us to customize how dates are printed. Pro tip, use an ISO 8601 compliant format and include the time zone. Trust me. This way, our log contains a lot more useful contextual information. For a lot of applications, this is a great place to stop. But if you really care about the quality of your log data, then I really suggest making one crucial change. Take a look at this log file. Glancing over it, I can visually distinguish different messages from each other. But notice that we have tracebacks in here. And what if log messages had new lines in them? If I wanted to parse this programmatically, I'd need to be able to parse back out all of the data that I put into it, but it's kind of just in free-form text with new lines that could be anywhere at this point. That's kind of intractable. The solution? Store persistent logs in JSON format so that they can be parsed easily later on. This is a change in how to convert a log record into a string, so that's the job of the formatter. We need a JSON formatter. But, oh wait, there's no built-in logging JSON formatter. There are a few you can pip install, but let's just write our own. Supposing we did, you'd think you'd be able to just set the class key here, and then pass in whatever arguments here, and those will be keyword arguments to the constructor. That's what's happening here with the handler, right? Nope. You can use your own class here using the class keyword, but if you do, then all of the keys are hard-coded to be the ones that the built-in uses. So I could use format and date format, but I couldn't create my own format keys. Why is it like this way? Great question. Moving on. Change class to open close paren, and then it will do what you actually want. Call this and pass this as a keyword argument. You'd have to do the same thing anywhere else in the config, like if I made my own custom handler that didn't have the same interface as the built-in one. Okay, well, with that weird road bump out of the way, let's continue. So we're going to pass in these format keys, which is going to be a dictionary where the key is the key that I want to appear in the log message, and the value here, like level name, is the variable that we're going to look up from the log record. Okay, so let's go ahead and write this class. We're in a new file here, and we just inherit from the built-in logging formatter. Nothing special in the init, we just store the format keys that we get from the config. Then we need to define this format function. This is a thing that takes the record and goes to a string. I'm using override here to indicate that we're overriding something from the parent class. It's not strictly necessary, but it's a good habit to get into marking these things. All we do is extract out the record data into a dictionary and then use the JSON module to dump that to a string. As far as actually extracting those fields goes, it's pretty simple. Regardless of the config, I chose to include the message and a timestamp in ISO format in UTC time zone. We pull in any exception data if it's present, using some parent methods in order to extract things out nicely. And for the rest of the keys, we just grab them from the attributes of the record. It's pretty straightforward, and you could probably do whatever you want here. And donezo, update the config to use the new JSON formatter, and we're good to go. Check our log file, and we see nicely formatted JSON. A slight warning though, this file is not valid JSON. Each line is valid JSON. This format is called JSON lines, and the common file extension is .jsonl. So to parse it, you just read the file line by line and parse each line as JSON. And double pro tip, now that we're outputting JSON, it's actually really easy to add lots of extra contextual information. To do this, we can just use the extra argument in one of our log calls. Give it a dictionary of extra information, and Python will stuff that onto the log record. Then just update your formatter to pull in those extra attributes. And now any extras will appear in our JSON. Here's the X hello. If you're getting too many logs and you'd like finer control over which ones to drop, then you might need a filter. The process of creating a custom filter is very similar to creating a custom formatter. Inherit from the built-in filter, then define your own override of the filter function. Given a record, you return a bool to indicate whether or not that record should be processed. So this non-error filter does kind of the opposite of setting the level to info. Setting the level to info would mean that you would only keep messages that were info, warning, error, critical. But setting this non-error filter would give you debug and info instead. You can also alter the record here, like if you wanted to censor private data, or return an altered copy. I'm not going to deal with filters for the rest of the video, but here's a homework exercise. Using this non-error filter, create a logging config that shows normal messages to standard out, but error messages to standard error. You're going to need the filter to prevent duplicates. Okay, surely there are no more glaring flaws with this logging setup, right? At the risk of using a forbidden word in Python, let's talk about performance. By its very nature, calling a log function results in I/O. If a user makes a request to my web app, and that results in 10 log messages, I don't want to add 10 round trips worth of time to my logging service before I respond to my user. But currently, that's what'll happen, because all logging calls are synchronous and blocking. The solution? Use a QueueHandler to log off the main thread. Collecting log data isn't the slow part. The slow part is sending it wherever it needs to go. A QueueHandler stores your log records in a queue without blocking, while an associated queue listener accepts those messages and passes them off to other handlers in another thread. In order to configure this, create a new QueueHandler in your config. The class is logging handlers QueueHandler, and then it accepts another list of handlers. These are the handlers that it dispatches to, so basically take the handlers that you had on the root handler before, put them here, and then change the QueueHandler to be your only handler on the root. This respect handler level, for some reason, is by default false, which results in the behavior of sending every message to every handler, regardless of log level. So yeah, that's probably not what we want, and I'm going to set this to true so that it does what you expect. There's one more thing we need to handle over here in the main file, which is that because the QueueHandler is starting a thread, that's not something that's going to happen automatically. When we set up our logging, we need to manually start that thread. We accomplish this by getting the QueueHandler by name, and then if it exists, we start its listener's thread. We also register an add_exit callback in order to call the listener's stop method and shut it down gracefully when the program ends. Alternatively, if you want to keep all the work inside the config, you could also subclass the QueueHandler class and make it do this stuff in its init. And success. We finally have a high-quality, parsable, multi-destination, non-blocking logging setup for our Python application. Feels good, doesn't it? But notice, I said logging for your application, not your library. Application authors know who their users are and know what kind of logs that they want to see. Whereas if you're writing library code, you don't know who your end user is, and you don't know what kind of logs they want. Conclusion, for library code, don't configure logging. You can still use logging, create loggers, log messages, and other important events, Just don't configure it with dictConfig or any other config. Let applications do the configuring. If a user doesn't configure logging, the default and expected behavior is that warnings and above will be printed to standard error. If a user of your library does configure logging, then don't interfere with what they want by adding handlers, formatters, or other things that they're not aware of. Finally, do you remember Log4j? It's an extremely popular logging library for Java that had a zero-day vulnerability wreak havoc and cause absolute pandemonium in the business world, as thousands of large products and services with millions or billions of users instantly became vulnerable to an easy-to-do, remote, arbitrary code execution vulnerability. At the heart of the vulnerability was a combination of logging user input combined with a plugin that allowed loading remote data as Java object data. Anyway, here's Python's makeLogRecord function that can be used to create log records manually, for example, from a pickled event received over the wire. I'm not saying this is actively vulnerable, but in case logging for P becomes a thing, called it. Thanks for watching, and remember, my company is mCoding, so if you're still not satisfied with your logging or other project setup, maybe we can help. Don't be afraid to reach out. Did you know that this entire channel is funded completely by donations? So huge thanks to everyone on Patreon and direct contributors for supporting the channel. If you'd like to support the channel, go to patreon.com/mcoding and sign up. And don't forget to subscribe and slap that like button an odd number of times. See ya in the next one.